All right, everybody, welcome to this webinar. We're going to start just here in a minute or two. Everybody's starting to kind of come in and sign on, so we'll start just in a minute. All righty. Welcome, everybody, to this webinar of the National Association of Invasive Plant Councils. My name is Chris Evans. I am the Vice President of the NAIPSI, and we decided to start these webinars. This is our first and hopefully a series of quarterly webinars dealing with invasive plant issues across the nation. So please check in with the at na-ipsi.org for future webinars coming up, and again, hopefully we'll have them quarterly. Before we begin, I kind of want to orient everybody to kind of how this webinar is going to work. We have 3 different presenters, and we'll be doing a little bit of switching between screen sharing, so you have to kind of let us do that. But if you want to ask a question, you can enter a question at any time through the question box that you should see on your screen. If you do that, you type it in at any time, it'll come, and the organizer, which is, there's 2 organizers, me and then Chuck Bargeron, we're the only people that are going to be able to see the questions. So what we're going to do is wait until the end of the presentations, and then we're going to ask all the questions then. So you can enter them in at any time you want. We'll just queue them up and we'll ask them then. Keep in mind that just for time's sake, if there's similar questions, a bunch of questions that kind of ask the same thing, I may summarize them or lump them together or something like that just to kind of keep time and keep it moving. But we will try to get to all the questions. And with that, I think that's the main orientation that everybody needs. I'm going to start here by introducing our speakers. So we have 3 presenters today for this webinar on aerial control of bush honeysuckle. The first is Andrew D'Alessandro with the U.S. Fish and Wildlife Service. Then we have Bob Cavney with Illinois Department of Natural Resources and Mike Lay with the Missouri Department of Conservation. So I'm going to just go ahead and send it right over to Andrew, and we can get this thing started. Let me see if I can figure it out here. All right, you should be good to go, Andrew.
All right, perfect. Thank you, Chris. Yeah, first I want to start off by thanking everybody for listening in and participating. You know, we understand it's a busy time of year with field season in full swing, so we're going to try to make it as informative as possible. You know, we'd like to thank the National Association of Invasive Plant Councils for hosting the webinar and for the opportunity to share what we're doing, but also we'd like to thank Chris Evans for inviting us to present. Our goal for the webinar isn't really to talk the entire time, but instead we want to provide the information we have and then open it up to the group for discussion. Bob and I here in Illinois are in the early stages of this project. Across the river in Missouri, Mike's a little further along, but our hope is to get some thoughtful feedback, suggestions, and new considerations as we prepare to move forward. First off, for the purposes of the presentation, when we refer to bush honeysuckle, we're talking specifically about Amur honeysuckle, or Lanister macii. Now we understand there are several other invasive lanisterous species that are commonly referred to as bush honeysuckle, but here we're specifically talking about Amur honeysuckle, as this is a species most prevalent at the sites that we manage and the projects that we do with landowners. You know, like numerous other non-native invasive plant species, bush honeysuckle was introduced from Asia in the late 1890s. It was originally planted for landscape and horticulture applications, and later the USDA, under the Soil and Conservation Service, promoted bush honeysuckle in wildlife habitat and soil conservation applications. This continued through the mid-80s, and in fact some cultivars were still available through the mid-90s. So at maturity, bush honeysuckle can approach upwards of 20 feet in height and 15 feet across, and it's really highly branched. In the late spring, you see about 1-inch white or pink flowers that appear, and it usually flowers for about 3 weeks. Usually the fruits mature in September, kind of September into October. And actually here in central Illinois, where I'm located, I saw the first fruits developing here this week. And it's with this fruit that we begin to see how bush honeysuckle can be so problematic. The number of fruits each plant produces is going to depend on the plant size, as well as where the plant is located. So research indicates that plants under a closed canopy habitat is going to produce less fruit than those located in more open or edge habitats. Each fruit can contain anywhere from 2 to 6 seeds. Typically, there's a pair of berries formed at the base of each leaf. So one can see how, as these plants increase in size and density, the number of seeds increases tremendously. When you couple that then with, these seeds are dispersed by frugivorous birds, you can see how there's just tremendous propagule pressure on the originating sites and those surrounding areas. Another problem with bush honeysuckle is it has a really high propensity to resprout after it's cutting. Any land manager out there that's worked with species like glossy buckthorn or common buckthorn, and some of these other invasive shrub species know that when you cut those stems and if you don't treat them with herbicide, you're really multiplying your problem. Well, bush honeysuckle responds in the same way. Next, which is problematic, is bush honeysuckle's extended leaf phenology. Here in central Illinois and Missouri, this species is one of the first to leaf out in the spring, and it retains its leaves well into the fall. It's actually not uncommon to see bush honeysuckle with green leaves into November. Because of this extended leaf phenology, bush honeysuckle is able to outcompete many of the species that grow underneath it. And also, this is a characteristic that makes the approach we're taking possible. After the first hard frost, the native species really go dormant, while bush honeysuckle is the only plant that remains with green leaves. And this is key to our ability to manage the species using this approach. So bush honeysuckle can invade a breadth of habitats, including abandoned pasture, open woodlands, and closed canopy forests. Once it becomes established, it tends to form these dense understory thickets that really have detrimental effects to the area. Numerous studies have shown forests and woodlands invaded with bush honeysuckle experience reduced species richness and diversity in both the native hardwood and herbaceous plant species. And because it leaves out so much earlier and retains leaves so much later, it essentially just shades everything out. Here in central Illinois and Missouri, this becomes a problem when you're managing for open woodlands, oak and hickory open woodlands. Other impacts include degradation of wildlife habitat. There was one study that showed that forests dominated by honeysuckle supported a different bird community. Resident and short distance migrants were 25 to 40% more abundant in the honeysuckle dominated sites compared to those with more native vegetation. The same study showed that the long distance migrants were 40% less numerous in the honeysuckle dominated sites than those in the native. There was another study that showed nests built in bush honeysuckles experience higher daily nest mortality than those nests built in native shrubs and trees. Actually, recently there was a paper that showed that leaf litter of bush honeysuckle in standing water yields significantly higher numbers of adult mosquitoes of a species that can transmit West Nile virus to humans. So as you can see, the problems extend well beyond the plant community. Here in central Illinois, we see on these sites that are dominated by honeysuckle an increased rate of erosion. When honeysuckle takes over, it becomes the dominant plant species. So you basically go from areas that historically had 100 to 200 stems per square meter to an area that maybe has 5 to 10. Essentially, there's no herbaceous layer. There's not enough stems to slow the movement of water. The geographic extent of bush honeysuckle is essentially the eastern half of the United States and then into the Midwest. As you can see here, this map taken from EdMaps indicates it's present in at least 33 states. The species is listed as invasive or regulated in some manner in at least 21. Literature review indicated it was about the early 2000s when bush honeysuckle started appearing on invasive species lists and getting consideration for regulation. Now, if we zoom in, we can see the species is pretty widespread in both Illinois and Missouri. It doesn't look that widespread in Missouri, but I think as Mike can attest, it's probably due to a lack of reporting in this database. So in general, managers use the same techniques on bush honeysuckle as they do many of the other invasive or undesirable shrub species. If you're working in small areas, one can hand pull the smaller seedlings or use some type of lever to pull the adult plants. If you're not removing the entire plant, then the most commonly used treatments are going to be with herbicide applications or a combination of a mechanical treatment paired with herbicide application. Because again, bush honeysuckle resprouts so vigorously, it has to be treated with herbicide in order to kill that stem. One of the most common methods is the cut and paint or the cut stump method. Simply cut the stem as close to the ground as possible, then treat it with 20 to 25% triclopyr or 20% glyphosate. Similarly, as shown here, you can perform the basal bark treatment and skip cutting the stem and just treat the bottom 12 to 15 inches with that 20 to 25% triclopyr. Another common approach is to do a foliar application where you simply spray the foliage of the plant to about a point of 50% coverage on all the leaves with 2% glyphosate. Some managers choose to use forestry mowers or flail grinders mounted on skid steers or other heavy equipment. Brand names like Fecon are the ones that come to mind here. Again, as you're cutting your stems, it's important that you have somebody coming behind and spraying, because if you don't, you're not going to achieve stem mortality. Of course, each of these methods are going to have their advantages and disadvantages, and some are more appropriate in certain situations than others. For instance, hand pulling is really only applicable in small areas as it's very labor intensive. Foliar applications, on the other hand, they can cover larger areas much more quickly, but you can see some non-target mortality depending on the time of year that you spray. The use of forestry mowers can clear large areas very quickly, but there's also a significant amount of ground disturbance as well as some non-target mortality. If an area has enough of an herbaceous layer and the appropriate overstory litter, prescribed fire can be used to control the seedlings and top kill some of the larger plants, but fire alone is not going to eradicate honeysuckle. So how much does it cost to manage bush honeysuckle? If one has access to volunteers or is doing it themselves, it's relatively cheap. Essentially, it's just the cost of the herbicide and the time. When you manage large areas, or if you work for state or federal agencies, or if you're working through some type of cost share program, this type of work usually gets contracted out. Here in central Illinois, this typically costs anywhere from $150 to $500 an acre. The cost is going to depend on several factors, such as the stem density of the honeysuckle, the slope of the area, and whether the contractor can use equipment or not. How far the actual project is, and mobilization costs for the contractors. If you're working in natural areas and have a specific prescription like hand cutting only, or if the project involves acreage with high stem densities, one can expect to be towards a higher range of that cost per acre. With this being the case, these projects can get cost prohibitive very quickly. This is especially true if you're working with a private landowner and working through a cost share program, because at the end of the day, there's only so much funding available, and we as agency folks and the landowner, we have to get the most bang for our buck. And with that, I'm going to pass it on to Mike Leahy with the Department of Conservation.
All right, let me go ahead and switch. So Mike, it should be up for you whenever you're ready.
Okay. This is Mike Leahy with the Missouri Department of Conservation, and I'm going to briefly go over our experiments here in Missouri with controlling bush honeysuckle using aerial herbicide application. We'll examine a pilot study conducted at DuPont Conservation Area and a replicated experimental design conducted in the St. Louis region, and discuss some of the initial results as well as some of the trade-offs and things that we've learned. DuPont Conservation Area is in northeast Missouri on steep river hills topography and consists of mature oak hickory woods as well as mixed hardwoods with a mixed degree of honeysuckle invasion. The really steep topography and budgetary constraints has stymied the managers there attempting to control bush honeysuckle at any meaningful scale. So because of the phenology of bush honeysuckle that Andrew alluded to earlier, a fall foliar application of an herbicide is an option for us during late October to mid-November, when most, but not all, of the native plant species are dormant, but the honeysuckle is still actively photosynthesizing. So our first experiment at DuPont Conservation Area was spraying on November 5th, 2009. The chemical was Roundup Pro. The cost per acre was $54 for both spraying and chemical, and we treated 75 acres with a fixed-wing airplane. We used 3 quarts per acre of Roundup Pro in a 5 gallons per acre solution of water, herbicide, surfactant, and drift agent solution. We deployed a simple monitoring design for this project to track changes in mature bush honeysuckle live stem density, the cover of bush honeysuckle foliage, and native woody understory and overstory species. The plots were sampled prior to spraying in the fall of 2009 and the following fall of 2010. We used pair t-test as well as graphs to demonstrate the treatment effect on the bush honeysuckle population. Following treatment, the bush honeysuckle mean live stem density per plot significantly declined over 90%. Likewise, the foliar cover also declined significantly by 87%. We didn't document any significant changes to native woody understory and overstory species. On the control plots, the bush honeysuckle stem density as well as the foliar cover did not change. These photos show the changes post-treatment in the honeysuckle, both in 2009 and then a second spraying that was done in 2010 using the same formulation. And we had similar results in 2010 as we had in 2009. So based on these promising results from the DuPont pilot study, we decided to use a better experimental design in a new research project which initiated to study the control of bush honeysuckle using the aerial spraying technique. The new study was going to be more comprehensive, and it was going to look at all the vascular plant species. So we developed a split plot, unbalanced design with repeated measures using both treatment and control plots, replicated for stands that had both high and low bush honeysuckle. And this is in the St. Louis region at Forest 44 Conservation Area in the Bush Conservation Area. High honeysuckle stems are pretty obvious. You can see the picture there. And then the low infestation sites had less than 50% median cover of bush honeysuckle at 4.5 feet above the ground. The study sites range from second to third growth, mature oak hickory woods, and they range from steeply sloping at Forest 44 Conservation Area to gently sloping to flat at Bush Conservation Area. These lands are typical of the suburban and ex-urban woodlots in the St. Louis region. However, due to past grazing and other abuses, the ground flora of these stands are typically of lower quality, even when they're not covered in bush honeysuckle. So these are not pristine natural areas that we were starting with. These are typical average conservation lands and not designated natural areas. Each control or treatment unit has 4 40-meter square overstory, understory sample plots, and then within each of these we have 4 1-meter square quadrats nested within it. This gives us a total of 56 40-meter square plots for the replicated design, including 224-meter square ground floor quadrats. We have 10 treatment units, and the treatment was 148 acres sprayed with 7 control units. We collected a wide variety of data, both on the bush honeysuckle, the native woody species in the overstory and understory, and all vascular plant species in the ground flora. Data were collected pre-treatment and post-treatment in multiple seasons, starting in spring 2013 and ending this past spring 2015. We specifically monitored ground flora in the current study to see which fall photosynthetically active plants might be negatively affected. We are also concerned with the toxicological effects. When we did the first treatments at DuPont Conservation Area, we used Roundup Pro. At DuPont, the areas did not have any ponds, wetlands, or perennial streams. Glyphosate itself, the chemical, is practically non-toxic to amphibians and aquatic invertebrates, as well as fish and mammals. However, the surfactants that are used in Roundup Pro can be quite toxic to aquatic organisms and amphibians. Because of this, we decided to switch the surfactant mix in our current experimental study. We consulted with our agency's toxicologist, the state herpetologist, and contacts were made with the U.S. Fish and Wildlife Service's Environmental Contaminants Program in Columbia, Missouri. Because of the surface water and toxicological concerns, we switched to using rodeo glyphosate product in combination with the surfactant Li-700 for the current study. Li-700 is a non-ionic surfactant that is rated as practically non-toxic to fish and aquatic invertebrates, as well as rats and rabbits. Furthermore, the timing of the spraying, early November in Missouri, is such that most reptiles and terrestrial insects are dormant. Aerial spraying was conducted by helicopter on November 15, 2013, at both Bush and Forest 44 conservation areas. 194 acres were treated in total, with 148 acres being in the experimental design. Our spray blocks range in size from 8 to 23 acres, and they were small and disjointed to allow for the experimental design. Because of this, we needed a helicopter to apply herbicide because we were in an urban airspace with tight turns and small scattered spray blocks. This really boosted the cost for the experiment, which was $126.50 per acre for the custom helicopter job and the chemical. We applied 3 3/4 quarts per acre of Roundup in a 15 gallons per acre spray volume of water and chemical mix. And again, we used the surfactant Li-700 at the rate of a quart per 100 gallons of spray volume. Just to note, these are preliminary results, and we still need to enter the data collected this past spring, and then we're going to work with the biometrician to conduct the statistical analyses based on the design that the biometrician gave us for this project. This graph shows that at Bush Conservation Area, in the sites that had a high initial honeysuckle infestation, we measured a 47% decline in the honeysuckle stem density after spraying. We also documented an 83% decline in the foliar cover post-spray. The control units at Bush changed little. Note that the foliar cover declined almost twice as much as the stem density, and the reason being that many of the honeysuckle stems were nearly completely defoliated, but still had just a few centimeters of live stem tissue, which still counted them as being live in the study. Here's an example of heavy honeysuckle mortality at Bush Conservation Area in Unit 1. Here's another before-after example, too, where you can see the person walking by the white oak in the before shot with quite a bit of honeysuckle behind him, and then the same shot with the dead honeysuckle stems in the foreground. The distribution of honeysuckle in the stands that have a low infestation rate are very patchy, so this results in a high amount of sampling error. At Bush Conservation Area, we documented about 50% declines in honeysuckle stem density, as well as foliar cover after treatment. At Forest 44 Conservation Area, in areas of high initial honeysuckle infestation, we measured a 48% decline in honeysuckle stem density and a 70% decline in honeysuckle foliar cover post-spray. This is an example of before-after photos showing the effects of the spraying at Forest 44 Conservation Area. At Forest 44, in sites of low initial honeysuckle infestation, we measured only a 14% decline in honeysuckle stem density after spraying. However, we documented a 63% decline in honeysuckle foliar cover post-spray. Again, many of the stems were still barely alive or stressed in the summer of 2014 on these sites. And the 2015 data shows a greater number of mortality. We just haven't analyzed that data yet. This picture shows stress honeysuckle stems in the foreground, which are almost completely defoliated, but were slightly resprouting along the stem. So we had to count these stems as live. And then, of course, in the background at forest 44, you can see the stems are still clearly alive. The treatment was more effective at bush conservation area than at forest 44, primarily because of the difficulty the helicopter operator had in trying to spray our treatment plots on pretty steep topography at forest 44 with scattered small treatment units. Meant that in some cases we didn't have as great of a target hit with the herbicide as we did at bush conservation area. As of this spring, we've noted no unusual mortality rate to native overstory or understory trees and shrubs except for one particular species, which is Carolina buckthorn, Rhamnus caroliniana, which unfortunately has a similar phenology to the Linicera macchiae, and that stays green through mid-November. However, all the other native plants showed, native woody plants showed under 1% mortality rates. Basically, they're the same in both the control and the treatment plots. Mean native ground flora species cover was almost double in those quads that had a light initial honeysuckle infestation level as compared to high infestation level quads. Again, just documenting what Andrew had said earlier, that in places where you have high honeysuckle, you have pretty much a non-existent ground flora. At bush, the mean cover of native ground flora species per quadrat decreased by 21% post-spraying in sites with high initial honeysuckle rates. On the other hand, the mean cover of exotic ground flora species per quadrat decreased by 95% during the same time period. And explicitly, the control plots also decreased by 50%. The mean cover of native ground flora species per quadrat declined by 26% post-spraying in sites with low initial honeysuckle infestation levels. This picture shows the recovery of trilliums on one of the plots after honeysuckle mortality. But what explains the decline in native ground flora cover observed in 2014 on the treatment plots? Although sedge cover was a small component of total ground cover across the quadrats pre-treatment, sedges were consistently found in the quadrats. The next series of slides illustrates what appears to be a pattern of sedge decline in the sprayed plots in 2014. The decline of sedges in the spray units likely explains the decrease in native ground flora cover per quadrat the season after spraying. The data we collected this past spring remains to be entered, but anecdotally the sedge cover appears to have rebounded in many of the plots based on our field observations. These three slides demonstrate the sedge decline between 2013 and 2014 at both conservation areas. Data collected this spring will tell us if the sedges have rebounded some. Christmas fern, Polystichum acrostichoides, is another species green at the time of spraying. In the treatment units at Forest 44, with low initial honeysuckle infestation rates, Christmas fern declined by just 12%. And based on our field observations, it appeared to readily resprout post-spraying and was doing very well this past spring in 2015. So to date, we can come up with this set of preliminary conclusions. The first is that aerial treatment with Roundup Pro appears to be more effective than rodeo plus LI700 surfactant, at least at the rate of the surfactant that we were using in killing honeysuckle. However, toxicological concerns of using standard glyphosate surfactants is an issue for aquatic life and amphibians. Aerial application of rodeo type glyphosate plus LI700 can provide for cost-effective control of bush honeysuckle in heavily infested stands, even on steep terrain. Increasing the rate of LI700 surfactant may help, and we need to do a little more research on that with some more trials. Aerial spraying has not had any significant effect on woody overstory and understory species, except for the Carolina buckthorn. The aerial application of glyphosate appears to negatively impact native sedges, at least in the short term, especially in areas with a light infestation of bush honeysuckle, where they're getting the full amount of spray. And Christmas ferns and mosses, we didn't show the data on mosses, appear to tolerate the spray treatment fine. So trade-offs need to be taken into account, and aerial spraying may not be the best approach in stands with a very light honeysuckle infestation rate and a diverse ground flora of plants green at the time of spraying, such as a really robust sedge layer. On the other hand, for heavily invaded stands, no treatment will eventually lead to the conversion of a forest or woodland to a honeysuckle shrubland. Analysis of bush honeysuckle mortality patterns and response to the ground flora will be conducted this winter, and we're hoping to have a full report available in 2016, as well as submit for a peer review publication. And of course, we're going to learn now more about ongoing efforts in Illinois, and we'll be doing more pilot studies here in Missouri in the future.
All righty, great. So I'm going to go ahead and switch it over to Bob. Let me go ahead and get it changed here. So you should be ready to go, Bob.
Okay. I'm Bob Caveney with the Illinois Department of Natural Resources, Private Lands and Watersheds Division. We have been, over this last year, testing aerial application as well. Last October, we went and saw a presentation Mike was putting on in Missouri, and got the idea to test it out ourselves as well to see how it works. So we've had a very short time period to set this up. I believe we went to that presentation in early October, and we set our plots up on October 31st of last year. So in Illinois, we decided to have two 80-acre sites in Macoupin County, Illinois, which is about 60 miles northeast of the St. Louis metro area. On those two sites, one site we were able to set up 15 anchor points. We followed the same sampling design as they did in Missouri, setting up 40-meter squared plots and testing the stem density of bush honeysuckle in each of those plots, as well as the full year coverage. Basically, we set up 40-meter square plots. We recorded the percent cover of the full year coverage of bush honeysuckle, as well as the number of live stems. We did this on October 31st of last year. We decided to follow the Missouri study and use the rodeo, the 3 quarts per acre, with the LI 700 surfactant. The treatment date for our study sites was on November 7th. The temperature that day was 55 degrees with a 4-mile-an-hour southeast wind. The total time it took to spray this treatment area was 15 minutes, and the total time it took to spray both treatment areas, which were within 1.5 miles of each other, was about 25 minutes total. So they were able to cover a lot of ground in a short period of time. This is the spraying report from the aerial application done by Holsworth Flying Service. As you can see, this was the 80 acres that had the survey plots set up on it as well. There were areas around the edge that was buffered in order to allow for drift, which I'll talk about a little bit later. We did have significant amounts of drift on the site. One of the major things, the cost for this type of treatment was $38 an acre is what it cost us, counting chemical, and the flying on of the chemical was $38 an acre, which is a lot less than conventional spraying methods. One big thing about this area here is this area north of the spray plot is a designated nature preserve. It's a remnant prairie, area. And some of the things that we found inside our spray area after the coverage gives us some hope on restoring remnants throughout the Midwest. So, as you can see, our before and after, the before pictures were taken October 31st, and we went back and did our resampling April 21st. Major reduction in foliar coverage, major reduction in stem density across the plot. Some of our areas, our kill rate was a little lower due to the fact that some of our selected anchor points were along the edge of our treatment area, and I believe the pilot probably was trying to compensate for drift issues with that, so our kill rate was a little lower than we expected. Here's another picture of the foliar reduction across our study site. What we found out is we had about a 60% stem reduction of honeysuckle, as well as nearly a 75% reduction in foliar coverage. That was using the 3 quarts of rodeo with the LI 700 surfactant at 2 quarts per 100 gallons. This may have been a little low due to the fact that, like I said, several of the treatment plots along the edge were not adequately covered. They were buffered, I believe, by the pilot to avoid the neighbor's property line and try to avoid potential issues there. But one thing we did have was a major sprouting of native vegetation, including shooting stars and trout lilies and that kind of stuff. We also found a couple remnant ridge or hill prairies on the property that had some rare species in them, including lead plant and Indian plantain and native Indian grass. So after removing the honeysuckle, these areas started to resprout as well, and we were able to locate them and open up around them a little more. One of the major issues that we had, especially on private lands, are drift issues. Even with anti-drift agents, we had significant drift. It's a long way to fall down from the tree canopy. I know in Missouri, doing it on their state conservation areas, they weren't as concerned with drift issues at that time, basically because they owned all the land around it. Our 80-acre sites are owned by private landowners, so we had to coordinate with all of the neighboring landowners as well about this. The picture right here shows that this is a non-sprayed area that was damaged by drift. We had about a 30% kill probably in some of our drift areas. It did knock it back pretty good, but once again, you know, being off target is not always a good thing, especially dealing with multiple landowners, such as in a private land situation. So some future considerations and conclusions from our first study here is it works best for heavy infestation, just like Mike suggested from the study over in Missouri. May want to avoid the low infestation sites with lots of native plants acting during that time, basically to mitigate the effects of putting that much chemical on the ground during a time when there may be a lot of native plants that are still actively photosynthesizing. Working with the neighboring landowners is going to be an ongoing thing. Most private land sites aren't large contiguous acreages. They may be anywhere from 40 to 160 acres that may have several different landowners surrounding them, as well as different types of development houses and that kind of stuff that will need to be taken into account. We'll also need to watch for the toxicity of reptiles and amphibians. I believe by using the rodeo and the LI 700 surfactant that we're trying to mitigate for these things, but it's something to be aware of. One main thing about heavy infestations is there may not be any diversity underneath the current canopy. By removing that foliar coverage of the honeysuckle, you'll get a sprout of native vegetation to come back. some future considerations. You know, as Mike said, using the rodeo, and we found it in our study as well, is that some stems are damaged or weak from the initial treatment, but they may not be totally dead. There may still be some leaves that are still alive or parts of the plant. So we're going to be looking into how we can do additional management to reduce the amount of honeysuckle that is still present on the ground after this type of spraying. Our current plan is to spray in the fall and then burn in the following spring or fall, and then do follow-up spot treatments following the prescribed burning. On the 2 sites that we did this last fall, we burned the site that we did not set up the study plots on. We burned it in April to test it, and we're still having pretty similar results out there as far as honeysuckle mortality. The treatment acreage, we're going to go out and resurvey it again this summer to standardize our sampling design, and then we plan on burning it this fall to help try set back the remainder of the stems out on that property, and to evaluate the success of follow-up treatments to reduce the stem density of bush honeysuckle. Another thing that we need to take into consideration is the fall deer and turkey hunters would need to be notified. Private land sites, especially in Illinois, the timing of the spraying right during the deer rut and archery bow season in Illinois, we're definitely going to have to work with the hunters as well as the landowners to coordinate all this so that there will not be someone in the woods during the spraying. So in Illinois, our future directions, we plan on expanding the study to other sites in west central Illinois. We're going to set up 15 sampling points on 15 properties throughout west central Illinois to get 225 sampling points where we plan on doing aerial spraying. We plan on using 3 quarts of rodeo, and then we're looking at the LI 700 surfactant, as Mike suggested in Missouri, about upping the rate of that, and we may go from 2 quarts per 100 gallons to 4 quarts per 100 gallons to see if additional surfactant will aid in the eradication of bush honeysuckle. So we're still working on setting up more test sites currently in Illinois, and look forward to continue testing it here this fall. I think that's all I have. So.
All right, great. Thanks, Bob. At this time, we're going to kind of jump into the question section, and it can be for any of the presenters or all of them, however we want to do it. And I'll just remind people that you can type your questions in to the question bar over on the side. And then what we'll do is I'll just read through them, and we'll kind of go from there. So one of the questions we had was on your helicopter applications, Mike. Specifically, they wanted to know how did you manage to get a helicopter to put on such a high total spray volume per acre? And they said they think most aerial applicators from helicopter, they say that they can't get to that high. It's 3 gallons total spray per acre or something like that's the highest.
Yeah, we just the helicopter that we operated, that we contracted with, was actually from Arkansas, and it was a very large helicopter that refueled and rewatered on site. And I would have, I'd have to ask them, but it was able to handle that capacity.
Okay, great. Did anybody, either of you, either of the studies, were there any evergreen trees in there, or do you have to have any concerns when you're trying to do this in an area where there's evergreens?
That would definitely be a concern. Fortunately, where we have done this is oak hickory. We do have some eastern red cedar, Juniperus virginiana, but we consider it in these communities an invasive species that comes in with fire suppression. However, we didn't have any eastern red cedar in any of our plots, and we didn't have any other evergreen coniferous species.
Okay.
We also
And
had red cedars in our plots in Illinois, or not inside the plots, but on the properties in Illinois, and there was really no effect to them.
okay. Okay. All right. Another question was about was on yours, Mike, with your use of, you tested Roundup Pro first and then you switched to Rodeo, and they were wondering about the rates. Now, the rate you used for Roundup was a lot higher than for Rodeo, or were they the same rates?
They were basically the same. For the glyphosate, the Rodeo, we used 3 3/4 quarts per acre, and for the Roundup Pro, we were using 3 quarts per acre.
Okay, so they were pretty similar.
Pretty similar.
Okay. This is for anybody here. What kind of weather conditions would you look for on a day to try this application or following an application?
Well, low wind speed is the key with the drift concerns, and the other concern is you want warmer temperatures so that the bush honeysuckle is actively photosynthesizing at that time. And you can't be stymied. We had a very severe frost before we were going to be doing some spraying this fall of 2014. And we decided not to spray because we felt that with that severe frost that the honeysuckle had shut down, which appeared to have done so. It was losing its leaves pretty soon afterwards.
Okay.
But the minimum wind speed is really key, as well as just clear conditions. Bob, you probably have more information on that.
Yeah, the wind speed is definitely a major factor. You're going back to those drift issues. I mean, if you're looking at a plane traveling at 130 mile an hour at 125 feet, they have a spectrum of 225 feet. So drift is definitely going to be an issue, and being able to buffer out for that. So the lower the wind speed, the better. I mean, in Illinois, we were able to spray in 2014, but we had about perfect conditions during the time of the spraying. It was 55 degrees the day of the spraying, as well as the next 2 days, full sunshine. So it was able to set in and actively, do the job.
Okay. Just a question for me: would this drift issue would be worse when you're using the plane and the helicopter? If you had a tight area where drift was an issue, just going to a helicopter may lessen that a little bit, or am I wrong on that?
Well, we plan on looking at that a little more this fall on some of our test sites that we're setting up. We are going to test fixed-wing aircraft as well as helicopters in Illinois. The only thing, which I haven't seen it firsthand, just me thinking out loud as far as the helicopter application, is the down pressure of the rotors, possibly pushing it off the property, basically pushing it against the ground and then spreading it out. And in smaller applications such as private lands, that may be an issue, but I do not have any data at this time.
Okay. One additional question, kind of still on the drift. How far from the test site were you seeing impacts or mortality from the drift?
We were probably seeing damage within 200 foot to 300 foot, depending on the direction that they sprayed. I believe they sprayed the paths in the north-south direction, so we had more drift on the areas of directions they were flying, not as much on the east-west boundaries where they were trying to mitigate for some of the drift issues.
Okay.
And that's about what we had in Missouri too, Chris. It's our control plots were a good half-mile away from the treatment plots. And the thing is, for us, all these areas were interior to larger conservation areas, so we didn't have, if there was an incidental take of honeysuckle outside the treatment units, it wasn't a problem, but it is obviously for private lands, or where you've got small conservation area and you're up against a boundary, it's going to become a big issue.
Okay.
Yep, our sampling units that were in the interior of the plot had a high mortality of stems. We had more live stems still along the edge of our sampling unit, where we had 3 anchor points, I believe, that had a number of live stems left.
Okay. Question here about your plans for prescribed fire afterwards. They said with heavy infestations, there's usually not much fuel to carry a fire, let alone to get it hot enough to kill woody stems. What type of fire behavior have you observed when burning previous heavy density honeysuckle sites?
Well, it depends on the canopy cover that you currently have there. The 2 sites that we did test it on are heavy oak hickory dominant canopies with bush honeysuckle infestation underneath. So we do have the leaf litter available on those sites. As far as the heavy infestations where you do not have the leaf litter, that's where follow-up treatments of just going in on the ground and doing spot spraying, I think, may be the better option. But if prescribed burning is an option, it's generally cheaper and very cost-effective in order to help manage these properties.
Question about timing and knowing when you can do this. What are the kind of the indicators that you see in the fall that lets you know you can do this or you can't do it? You know, the beginning and the end.
Yeah, so essentially what you're going to be looking for is that hard frost, and that's important for 2 reasons. One, you need those native species to go dormant, and then secondly, you need that hard frost to then knock the leaves off your canopy trees, because when you're applying from above, that herbicide needs to get down through the canopy to that understory where the honeysuckle is. So you definitely need the hard frost, but then, you know, if you're looking at forecasts, you know, you're looking for higher daytime temperatures, you know, after those frosts have occurred.
Okay. So
and most of the leaves on the oak trees have fallen off. I mean, you know, they may be dead, but they need to be on the ground or your overstory canopy, so there's less surface area to allow that chemical to get down to the understory.
Well, just a follow-up from me. In this area of the Midwest, what's your typical, you think, a realistic spray window, time-wise, in the fall that you can do this? Like, how long would it be?
You probably have a 2-week window, maybe.
Okay.
It's going to be a very short duration. I mean, it all depends on the year. You may have a very early hard frost and then warm back up for a couple weeks. But it may also just get cold and turn off cold like it did in Missouri last year, and you may have no window to do it. So it's going to be something that
the drawbacks, Chris. I'd say the same thing. I mean, it's really right before or right at the very beginning of our typical deer firearm season, which Bob alluded to in terms of issues with people being in the woods, but it's right about that time, early November. The first 2 weeks in November for us have been when that window has appeared. But I would say anywhere from the last 2 weeks of October, you know, if you had a warm November, it could potentially go to later November.
Yeah.
So what do you look for do you look for the yellowing of the honeysuckle? What tells you that you're done for the year?
Just the severe yellowing of the honeysuckle, and when it's actually dropping leaves, some of the leaves, and just it loses that green, lime green tint, and it goes from yellow to kind of a faded yellow.
Okay, great.
But unfortunately, yeah, there's not an exact prescription for that.
Okay, well, that's good to know. I mean, it's good that you've got to kind of do it by feel. I had a question from somebody about the Illinois study. They were just asking, they didn't catch what the total spray volume per acre was for you guys.
It was 5 gallons an acre.
Total spray volume?
Yeah.
Okay, great. Somebody was asking, have you seen any luck in these areas if you had Japanese honeysuckle?
We did have Japanese honeysuckle on the site that we set up plots. It did kill it in the trees, brought it all to the ground, but underneath the honeysuckle plants, the larger plants, there were still areas where the Japanese honeysuckle was alive. However, like I said, it brought it all to the ground. Everything that was in the trees was killed, and brought to the ground. We also killed garlic mustard rosettes, and we did set back the multiflora rose in some areas. The stems were still actively photosynthesizing at that time, but it came out. Yeah.
Okay. We had a question here from somebody talking about kind of a size that you need to treat in terms of reinfestation, things like that, or at what size is it? How big do you have to go before it's an effective treatment? I guess is what they're trying to ask.
Well, it's got to be a big enough area to basically have a price that an aerial spray operator is going to want to treat, which seems to be, at least for us, at least over 50 acres to make it, a large enough area, to have it be competitive for somebody to invest their equipment in doing the spraying. That's been the main limiting factor, rather than the ecology of the site.
Right. And our aerial applicator here in Illinois, he was able to treat 160 acres with one plane load. So yeah, really, I think that's more of a question with the applicator, the equipment that he has, and what he's willing to do. So yeah, I mean, we did two 80-acre sites with one plane load, and that was enough for him to
you
fly.
Carry 100 gallons of water.
Yeah.
Okay. Good deal. Here's a question that just asked, are the slides from this program available online? And so I will say yes, they will be. We are recording this, and we're going to have it available at the NAIPSI's website. That is na-ipc.org. So you can look at this. It'll take a few days to get it up, but that's where the recordings will be at. Another question, a question here about treatments here, and I'll just read it out. It says, our experiments with basil bark and foliar that have resulted in significant foliage and cover reductions. However, we have also found that plants that may have been 80 to 90% defoliated have regained coverage. In some plots, rebuilding 50 to 70% of the original leaf area. Do you have a concern or observational information on that issue? Look, you think you guys, the ones that you said just had a little bit of foliage left, are they go ahead and dying that second year, or do you see them recovering?
Yeah, so here in Illinois, we just did our first application last fall, and here this summer we see those, those retarded stems where they're just a little bit of growth. So we don't know yet if those are going to come back or not. We did a smaller study with some of those, cut stump basil bark techniques a few years back. And, what we saw there is with those stems, the ones that had that, very minimal retarded growth that we had to count as a live stem based on our protocol, when we came back the following year, so in year 2, those stems were dead. So I guess here in Illinois, that remains to be seen. I don't know, what do you think, Mike?
Well, we're going to analyze our data. I know in 2014, a lot of those stems were still alive that had just a small amount of resprout or funny growth form. But in 2015, a number of those had died. Although we need to actually look at the data to see what success rate we're having, and then we're going to try to track a subset of our plots through time with ones that are treated with prescribed fire and ones that aren't. So that'll be an interesting documentation of whether these things come back, and if you do use prescribed fire, can that eliminate the remaining set of larger stems. But so far it seems like there are some issues where some of those stems may rebound, but we don't have any, we haven't analyzed the data yet to really say what percent.
Okay. We had a comment here from somebody from southern Iowa, and they said that they tried this on November 9th of last year in southern Iowa at 3 quarts an acre Roundup Pro, using helicopter and electrostatic sprayer at 1 gallon per acre total spray volume. And they said they had optimum conditions of the day. It turned cold the following day and stayed cool, but they were pretty disappointed with the results. So they're interested in hearing from you guys what you thought, maybe the reasons they got those poor results, and if you think there's something they could do differently.
Yeah, I mean, I think Bob spoke about it here in Illinois. We had several of the hard frosts, so a lot of the canopy, a lot of those oak and hickory leaves, they were already shed. So it was pretty much open. And then it was cold mornings and then warm afternoons for several days after we applied, and there was no precipitation. So I think we had, just anecdotally, we had ideal conditions for that. It's tough to say. It's really tough to say.
And that's what we plan on expanding, future research on different amounts of the LI 700 surfactant, as well as follow-up treatments such as the prescribed burning and trying to document that a little better. Like I said, we're in our first year, but we're expanding it here this fall and hopefully be spraying 15 different sites and then breaking those down into burn units and non-burn units and that kind of stuff going into the future. So.
Yeah, the only thing I could offer, Chris, that Bob and Andrew did would be it did sound like the spray volume was low. Was it 1 gallon?
Electrostatic, yeah, 1 gallon.
Yeah, and that it may be that there wasn't enough volume of water and material to get down, onto the honeysuckle stem. It's a possibility. Yeah, one of the downsides of this treatment too is, like we said, it is weather dependent and dependent on the phenology of the honeysuckle. It's a lot like prescribed burning. The results can be quite variable depending on so many different variables that go into it.
Okay. So with a follow-up treatment afterwards, especially with these heavy stands, do you have an approximate cost of what the follow-up treatments costed you?
So when we do, when we contract these projects out here in Central Illinois anyway, the prices vary, but usually that second year follow-up is much less, anywhere from $75 to $150 an acre is what we've been seeing. But again, that's going to depend on the site conditions.
We're going to be using prescribed burn first and then do an evaluation whether we need to do a follow-up spot treatment or not. And we'll be doing that this season. But it would be, I would imagine it would be a lot less. I would imagine compared to on the ground, $300 to $500 an acre would be somewhere from $70 to $100 an acre if we had to do spot treatment contract work.
Okay, great. Just a question here somebody had is, how long do people need to be out of the sprayed area after the spraying is performed?
Probably 24 hours, I would say.
Yeah, that'll be on the label.
Yeah, label directions.
Okay, great.
It's on the label, yeah.
Okay. A question for me, just not a follow-up to that one, but just in general about landowners. And you talked about this being hunting season. People are out there in the woods. How, in general, especially I guess for the Illinois people that have been doing this on private lands, how has this been received by landowners? Are they typically pretty pro this? Or are they worried about it? Or what's been the reception from them?
The one property that we set up the study sites, all the landowners were very understanding. They pretty much said, kill it all, and we're fine with the spray lines. We did have a landowner on the second property that we did not set up study sites that was a little freaked out by planes streaking over top of his house at 150 miles an hour, and not sure what was going on. So that's coming back. Most of the landowners we've met or been working with so far have not had an issue with it. I imagine it will be more of an issue as we extrapolate the study and dealing with more landowners and that out there. So it is something that's definitely on our radar, and we know that we have to look into it to make sure everybody's happy and everything works out in the end. So.
Okay, great.
For us, we had to close down parts of the conservation areas at both Forest 44 and Bush Conservation Area. The fall deer and turkey hunting is our managed hunt, so that was another confounding factor. We had to work around those dates. But we actually had to close off the conservation area, parts of it to public use. We also had a press release in the St. Louis area. We received a little bit of negative publicity from that, but for the most part, there was little negative publicity, and it didn't persist. At DuPont Conservation Area, we had to close off portions of the area to deer hunting and sit out there, post the area, and then make sure early that morning there were no cars or vehicles or folks in the area with a flyover once, just to make sure no one was down there. So that can be an issue. But in the urban area where we would expect most of the concern about aerial herbicide spraying on public areas where we have public fishing lakes, surprisingly we received fairly little negative feedback from the public.
Excellent. Okay. Just a reminder to everybody listening in, we're kind of getting close to the end of my question queue, so if you have questions, go ahead and type them in now. So following up with, there's another question following up about landowners. They would like to know, in Illinois, how did you find your landowners to do this research on?
Our current landowners that we're working with are enrolled in the private lands programs in Illinois, including the Recreational Access Program. So we've been working with those landowners enrolled into our state private lands programs.
Okay, great. Somebody wanted to know if there's a noticeable reduction in deer and turkey or any wildlife within the sample areas after the application, and if so, how long?
We can't really speak to that here in Illinois. I mean, we weren't looking at that.
And they deer hunted both of the properties all of last fall, so after the application, and that, once again, that's just personal communications with the hunters and the landowners on that property, but they still did deer hunt last fall on those properties, as well as the IRAP program leased the turkey hunting for the youth on those, so we had turkey hunters on those properties as well here this spring.
Okay, great. Somebody looked up rodeo's label, and they said the return interval in rodeo is 4 hours. So I just wanted to mention that.
Thank you.
Question here about, said somebody mentioned in the answer to a question that this treatment was could kill garlic mustard rosettes as well. Is anybody keeping any records on the control of garlic mustard using this, or have any idea on the percentage of control?
We just had ours in Illinois based on observation, walking across the site. We didn't have any garlic mustard within our plots that I know of. We're looking at expanding into looking at more of the vegetation pre and post spraying on the ground. We haven't quite got that far yet. So the garlic mustard, like I said, was just from visual observation across the property.
Okay.
For the Missouri study, within our ground floor plots, we fortunately didn't have any garlic mustard. We're just getting garlic mustard in those areas.
Well, that's unusual to hear.
So we don't have any data to really say one way or the other on that particular species yet.
Okay. We had a comment here from somebody that says they're in Illinois, and if a county park area would like to become a test site, one, is that possible, and two, who would they contact to ask that?
Well, they can contact me here at the DNR, and my phone number, it can be found on the DNR website. So my office phone's 217-782-5719.
All right, great. Thanks, Bob. Any more questions? You got to get them in now because we're getting ready to wrap things up. I think that's all the questions we've had. I don't have any other ones. Any other last comments or any summary statements that you guys want to make?
Just thanks everybody for their time today, listening in, and all the questions that we got.
All righty. With that, I think we'll go ahead and call it into this webinar. Again, we're going to have this recorded and made available on the NAIPSI website, and keep an eye out for future webinars. We hope to have these quarterly. All right, thank you, everybody.
Thank you.
Thank you.